I'll give present screen. My screen is visible or not?
Yeah, it's visible.
Yeah, it's visible.
Okay, okay, fine, ma'am.
Right.
Shall I start?
Yeah, yeah, yeah.
Yeah, yeah,
Today,
yeah.
what you are
Today,
going to
what you are
train them?
going to train them?
I will train them like a flow or a cylinder today.
Okay, okay.
Okay, okay.
Fine,
Ah,
Fine.
fine.
just
Okay,
first
Okay.
they should learn that one and
yes,
how to do
Yes.
meshing for a small object.
yes.
Then
Yes.
later we will
So,
do one by one.
So
cylinder will be a
cylinder will be
3D
a 3D
cylinder.
cylinder.
No, 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 ma'am. First 2D.
2D, 2D,
2D.
Once
alright.
2D.
2D,
All
that
right.
steps they know means then they can go with the other objects.
Right.
Then
Right.
3D I will teach.
Okay, okay.
Okay.
Please
Okay.
carry on.
Please carry on.
Because first initially 2D, 3D means even for meshing itself it will take lot of time.
Yeah, yeah. Just
Yeah,
now I
yeah.
just
Just now I
discussing
just
that.
discussing that.
That's why.
Yeah.
So 2D means it will we will finish it off within this time,
Right.
specified time. For 3D, for up to geometry and meshing itself, they will need to practice. I will give the steps and they will practice like that.
Right.
If it is
Right.
going means good.
Right.
Please. Okay.
Please. Okay.
Okay. Continue.
Okay.
Okay.
Continue.
So in last class itself, we have seen how to use the interface or workbench in Ansys. So today's session, we will be doing one exercise about flow over a cylinder. So for that, what we need to do is initially the same steps we are following the same steps. Either you can choose fluid flow fluent from workbench, or else if good way is like you can go with this one geometry meshing. So if anything happens means you can easily delete it off. So here what I'm doing is I'm just opening the geometry. I want to create a cylinder. Now our exercise is limited to 2D analysis. So what we are going to do is to make one circle and make a control volume over that. So once that is done means we can go with how we can visualize the flow or a cylinder at a particular Reynolds number or a particular velocity through Ansys. So I have opened designer modeler. So in that, in last class itself, I told initially we need to set a plane. So I am setting XY plane. If you want, you can choose any other plane. But if that plane is chosen, means accordingly you have to give the boundary conditions. That is the only difficulty here. So better ways to choose XY plane. And if you are see this designer modeler, we can just what is it? Straight away you can import the geometry. But the only thing is like if you want to import some geometry, means it should be in IGS file. So for IGS file, you can I click file here, import external geometry file. So if any file is there, means you can straight away import that one. So for me here, so many things were there. I will show if it is imported means how the file will look like. So this one is a 3D file. So right now we are not going to do 3D. So for importing a file, it should be the procedure is like this: import external geometry file. In that you can import any. If the file is in IGS format, you can import that one. So suppose I want to import another one file, means see I can delete it here. File import. So here file if I want to import means, but you have to give generate. Once it is generated only, the file will be here. This one is a different file. So like this, if you want to import anything, you can straight away choose the IGS file and you can import that one. So right now what I'm doing is I'm drawing a circle, and over that circle I want to see the flow over a circle or a flow or a cylinder. So what I'm doing is first initially I'm drawing one circle with center point only. So here circle is drawn. So I'm going to give the dimensions for that circle. So dimensions, here it is. If you want to make see units, that should be carefully checked. So here it is. The circle is 6 meter. If you don't want that much means 100 only I want means I can straight away give 100 See, so 100 So this is a cylinder. Now, once cylinder is made or the 2D circle is made, I want to see or I want to do analysis over the circular cylinder. That means I want to do an external analysis. So to do that, come as I told earlier itself in last class and all, for doing some CFD analysis, we need to choose one boundary. If the boundary is there only, computer can recognize that this is suitable for doing whatever analysis you want to do. So here, my preference is like I want to do one external flow analysis over a cylinder. So I want to make one control volume. This control volume in normally when you're studying CFD and all, you will learn like you can go with some what to say for a flow or a cylinder. We can go with some rectangular control volume. For airfoil means we can go with some C-type control volume. Like that, so many different types of control volumes are there that we will prefer depend upon our requirement. So here I am going with one rectangular control volume. I'm drawing one rectangle here, and for this rectangular, again I am going to give the dimensions for this one. So So it is like for giving dimensions, there are certain thumb rules were there. At least the in front of the body, we should have like it should be like 5 times, minimum 5 times it should be like. So the diameter of the uh, cylinder is like 100 We can give like into 5 times. So like 500 we can give. So similar way, bottom side also we can provide all dimensions which should provide. So here again I am this side I am giving the bottom side. Here also it is like 500 In front also it should be five times the diameter of the object. So this is a cylinder which has a diameter of 100 So our control volume should be like 5 times more than that. Minimum 5 times it should be. So in front also it should be five times. Back side it should be like minimum 10 times. So here I'm specifying the dimensions. So all sides dimensions are given. So you can check here. Here also it is like 500 and this side it can be like 10 times means 1000 So this is our control volume. This we can increase or decrease depend upon our requirement. Suppose you want to see a cylinder inside a hollow pipe where where water is flowing means you can increase this yeah L6. That means this front side and back side. Suppose if I want to do that means I can give here 1000. Here I can give 2000. So that this will be like it will behave like, or if you want to increase further also we can do. So right now we made the control volume. Now there is one option called we should create a surface because now the sketch is there. If a surface is created, it will behave like a 2D surface. So if for the 2D surface, we will know it will remember like where the flow should go or where the analysis should be done. So for that purpose, there is one option called concept surface from sketches. Just select the sketch I have drawn in XY plane. So I'm just selecting by that one only. Sketch generator. So you can see surface is created over the cylinder and in between the boundary. So this is the boundary or the control volume where the or domain where the surface is created. So computer will recognize only this surface where the flow should be. So now you'll be asking one general question like, sir, which will be the boundary conditions, or whether we need to give naming. You can give naming here or else in the meshing. After that, we cannot give namings. So now for doing that, there is a selection filter. Here there is a, it is like a point select. Next one is the edge select. Third one is the face select, and fourth one is the body select. So if I'm selecting body means total body will be selected. Selecting face means only that face will get selected. Selecting the edge means only the edge which is there that will be getting selected. Point means or vertex means only the points will be getting selected. So right now I'm selecting only the lines or edges. So this side I'm giving that edges like giving a name for that one, that is inlet. So after naming that, we should give generator. Similar way, the other side that will be the outlet. So here give outlet. Now this both region will behave like a valve. Sorry, before that generate I need to give. So this will behave like a valve. So I'm giving the naming for that one as valve. Generate. So now your domain is generated. So this is how we need to make the domain. For suppose if you want to do one rectangle means draw a rectangle, sorry, square or some other object means you can draw here, then make one control volume for that and do the analysis. This is a simple way. Even for airfoil also it's like that. Only for airfoil we can go with the C grade, that will be better. And here also one more thing we can do. First I will show general type meshing, and next we will go with some different types. If I want to have some structured grids over here means also we can do. So so many options were there, but that is somewhat difficult. We should split the things into phases, and we should give appropriate name for each phases. So for that, suppose O grid is there means easily we can provide that one. For this type of control element, it is quite difficult, but for O grid type and all means easily we can split this region one split, here one split, so that we will get four phases. So this line will match the mesh of the outer boundary. Here, if it so means we need to divide accordingly so that it will behave in that manner. So the mesh will be created in that manner. So now domain is created. So once again give generator and give close. You can close this one. So the green tick is given. So the geometry part is finished. Next is the meshing part. So I'm dragging the mesh and putting in geometry. Double click on the mesh. So one more thing here. See, there is one function called Reynolds number calculator and Y plus calculator. That calculators is there. Straight away, you can keep like Y plus calculator. You can see here. See, here you can see the free stream velocity. Suppose your free stream velocity, that means you want to see the flow over a cylinder at 1 meter per second or 2 meter per second. I'm just giving 2 meter per second. This is, and here the boundary layer length they asked. So the boundary layer length means the length of the or diameter of the or a cylinder. Okay. So here we can give like how much is this diameter is 100 mm. So in terms of mm, you can give 0.1. And this is the y plus value. This depends. This I will later clearly explain. Now for what to say, this y plus is like it will give for different turbulence condition is there in Ansys. We discussed earlier like laminar is there, no, not laminar, sorry. Spallet alamus is there, then K omega, K epsilon, then so many other things were there. So for each type, the boundary layer is different. So if I want to create or to study the near to wall conditions, or near to wall how the flow is behaving, then I want to give accordingly the y plus conditions. So if in that factor we should set the y plus value. Suppose I am using some normal what to say some Sparlet LMS, means you can go with some 30 in here, 30 to 100. There are some standard values. So now if I'm creating, means this will be the first what is it, first wall distance from wall, first cell will be created at this height, and this will be your Knowledge number for this particular velocity and particular this one. Suppose if you want to change the fluid to be some water, means for accordingly we should change the conditions. So this value we need to give in our mesh for getting the high quality meshes. So right now we will be doing some basic things. So here, see, once this is created, it will be like this. So click on mesh, and there will be details. In some cases, see, for Ansys, please don't close the things which is shown here. If you close, means better go with the reset layout, or else in manage you can see all the things. Here you can select whatever. If some cases students will, or some users, what they will do, they will close all the tabs. So if the tabs are closed, means again you will find it difficult to bring back and position there. So what you do, if in that case you can manage in that all the tabs will be there. So whatever you want, the worksheet or messages or report or print view, whatever there, you can get it from here, and accordingly how to drag and put there. Or else better you just give restore layout. So whatever is there, that will be restored. So yeah, in meshing, the first thing you have to check is the details. In details, there are different type of physics is there. There here, what we are going to do is a CFD. So I'm just selecting CFD, and here element sizes. Element size means, see, this is your control volume. In that we know the cylinder itself, it is 100 mm, and the default value is 158 mm. So think that 158 mm element size means each elements will be created in 158 mm. Okay, I will show. See here, if I'm giving a right click and generate mesh, means see how the mesh will be created. See, this is how. So the element size which is created, that will be like a 158 mm size. Suppose I am changing this to like a 100 mm. Now again I'm giving generator. See how the mesh will be created. See, it is the size is reduced. If I want to reduce it further, means again I can give like each cell I want to make that as a 10 mm size. So 10 mm means near to the airfoil. The here you can see the mesh is getting adjusted due to the one boundary there. That boundary is the cylinder shape. So that because of that circular shape, the cells are getting adjusted. In Ansys, this automatically the cells will get adjusted for according to the mesh. So here it is like now I am giving 10 mm. So for 10 mm, here the mesh will be created. And you can see here there is one option called a defracture. In this feature, our mesh should not go beyond this limit. If it goes beyond this limit, error will come. Okay. So other things we can, and the smoothing we can give this is high, and inflation here only we need to give, because I told the first cell which is created. Suppose if you want to know how the boundary over the cylinder is uh, how the boundary is there, and how the flow occurs, whether there is a recirculation or the flow is straight, this and all, if you want to know, you have to give the inflation layers. Otherwise mesh will not be created near to the boundary wall. That I will show. Suppose whatever we are giving for that itself, what values we are getting, that we will know after the analysis. Okay, so I'm giving the total thickness and the boundary layer or the inflation layers are in CFD. There is a term called prism layer. Both are same only. Prism and this inflation layers are same. If I want the inflation layer to be 20, means 20 inflation layers will be formed, and we have to define the thickness of that layer. See, already the mesh what I want to create, I have given the value like 10 mm, and we know the diameter of the total cylinder is like 100 mm, and this I have given 20 layer thickness. Here itself we have uh, what to say, we found that it is like the wall thickness is like first estimated first wall thickness is like 0.003. So if I am giving 0.003 means the first layer thickness here, first layer thickness is there. That is that wall is 0.003. So I can go up to like a 0.03 or zero 0.1 like that we can go for. So now I am giving total thickness. Total thickness means the boundary layer. I'll show how it will be here only. I'll show. Suppose this is your cylinder, and the first layer should be formed like a, so we have seen some mesh formation here. So these are the mesh formations, and you can see the first layer. My pointer is in I'm pointing that only. This is the first layer. So you can see how much distance the first layer is found. This is the distance first layer is formed. If in this case you cannot see any flow vectors or how the flow is going around the body. So if you want to see more accurately means we need to give the first layer thickness. That will be like more closer to the wall. So in this image, you can see that the first layer which is formed is like very closer to the wall. So similar way, we need to make our mesh. So only I'm giving this value. So here I am giving like the total thickness will be like 0.03. 0.003 is the first layer. So I'm giving the 20 layers should be in this way. So now we can give here sizing. So sizing I'm giving. In sizing we need to select the edges, or here I am just selecting the edge, apply this. You can either give element size or else you can give number of divisions. So this number of divisions means this cylinder will be meshed by, let's say, like 200. So 200 means see how the mesh size will be like. It will be very fine. Suppose I am giving like 100, so the mesh will be formed a little bit. What to say? Uh, Somewhat it is good only, but still, if you go more, if you want more fine mesh, we can go with some more number of divisions or element size. So here I am giving number of divisions. So this it's a single edge easily can divided by the number of divisions. Then give face meshing, apply, select and apply. Here quadrilateral is enough. If you want the triangular type mesh, that also can be created. Then one more thing is there. We should give inflation inside also. That is the most important thing. So I am selecting the face, and here boundary you have to specify this layer, and here also whatever you gave outside that should be same. So I have given 20 layers. So this one I'm just deleting. It will not apply here. If inflation is given, this will not be applied. Either you can go with the method, or this much is more than enough. Now I'm giving generate. It will take some time, but once it is generated, you can see how the mesh is created. So up to this, anyone have any doubt? Because it will take some time. Till then, if you have any doubt, means you can clarify. It is created. Guys, if you have any doubt, means you can ask. Actually, Ansys is the most easiest one. Apart from that, if you have 3D experience, in 3D experience, Simula is there. There you can do all analysis, CFD analysis, or else Star CCM is there. Even in console also you can do the analysis, or else OpenForm, SU2. But thing is like without a proper training in SU2 and OpenForm, you cannot do any analysis. But Star CGM also almost similar only. And some other normal softwares is there like SolidWorks and also like Autodesk CFD. So in that and all, problem is like if you are using that, it will not give that much accurate results. General results we will get, but that is okay for your purpose and all. It is okay, but if you are going for some high-end publications or some other industrial applications, that will not work out. That's why we are most probably we are relying on this one. See, now you can see the inflation layers which is formed. So in this layers, this is the inflation layers. Now in this inflation layers, we can see the first cell which is formed, and I have given the total is 10 layer. So 10 layer is formed over this. After that, that will be connected to the outer region where we are getting the normal quadrilateral meshes. So now one thing I forget, that is the inlet I have given, outlet I have given, and wall is given. But this cylinder which is not given, so that should be named. So I'm giving name for that one. That is cylinder. So cylinder I have given. Now this meshing is done. You can see all tick marks. So this is over. Once again, if you want, you can see the mesh. Now we can close it. So mesh is over. So next part is like a fluent. So drag and put the fluent over mesh, and after that give update. That is the important part. So now setup, double click on setup. I told last time itself double precision we have to give, and 4 core give start. So we can see the domain which is created with meshes. Here also you can see the proper mesh, and there is one indication like blue color and red color that indicates that this blue color indicates the blue color arrows are the inlet and red color arrows are the outlet. So here again I'm telling, if you are going for a steady state means you can choose steady, or a transient analysis means better you can do that one. So here again energy on, and the thing is like it is like we have chosen for 2 meter per second, so you can give laminar only. And if you want to change, suppose I want to do analysis over the flow flow over the cylinder is the fluid which is I'm choosing is water means see here fluent database, click on fluent database. Here water liquid is there, select that one, copy, give copy, so that automatically water will be chosen. So here you will get water. After doing that, there is one more condition like a fluid surface body will be there, because this is the surface body. There you have to click that or choose which one, whether it is air or water. So I am just selecting water to see. See, this is how, if you want to do any material change means you can do here. Then the boundary condition. So here velocity inlet, I am just going with velocity inlet only. And the velocity which I am going to give is like 2 meter per second. So I am just giving 2 meter per second, close. Then cylinder, it should be wall, and here also wall, that is wall only. We need to ensure what type of boundary condition is given. Inlet should be velocity inlet, outlet should be the pressure outlet, and other should be wall. And again, next, no need of other things which is mentioned. This dynamic mesh interface and all. Suppose you are doing some like a flow or a rotating body means there, here everything, there is no interface between meshes. But if this cylinder is rotating, if you want to make this cylinder rotate, and then we need to create one interface between the cylinder and also the mesh. Things it is not required. So I'm just giving the reference zone as a surface, and the compute from, we need to compute from inlet. And other things like here let it be, or else you can, if you want, you can change to symbol also. And that and all depend upon the conditions we need to change. Right now it is not required. And this is the report plots. Just give drag. We are going to check drag means cylinder. Here give drag, print to console. Then again lift, select this cylinder. Here you provide naming as lift. So drag and lift plot is created. So automatically you can see when doing the analysis, you can see how the drag and lift over the cylinder is. So we are computing from inlet, so it will be like uh, compute from inlet and give initialization. Once it is the initialization is done, we can give run calculation. There you give like 200 or 300 iteration. I'm just giving 300 iteration because it's for our small example only I'm showing. So I'm giving this one, and automatically the process will get started. Can see the lift and drag for a particular cylinder, how the plots you can see the drag also. These are the residuals and the meshing bar. For a dynamic meshing or a transient, if the mesh want to change means here you can see the mesh update also. So the calculation is got completed. Now you can see the lift and drag plot, and you can see the calculations. Here, how much is the values? Still, it is not converged. So we will get some random values only, not random. Finally, after convergence only we need to take. So right now I'm just giving random boundary conditions and random fine. We are. I'm showing just how the things will work out here. And if you want to see the results here, means here also we can see the results, or else in separate results also you can see. Suppose I want to see the xy plot over, that means any pressure plot or pressure coefficient over, that means, see, I'm just selecting xy plot in that pressure. I'm just choosing pressure coefficient and over a cylinder and generating the plot. So this is how the plot will be like over a cylinder for this particular velocity. Now, if I want to see the contour, means close here, better way is to see in results only. So I'm closing that. Now drag and put the results. See, this is how the pressure over a cylinder at 2 meter per second. We have given 2 meter per second, and this will be the velocity. And you can see how the velocity is. We have created everything. The velocity contour over the surface. This is a velocity, and you can see the velocity is getting slowed down to zero at the front part and also at the rear part. If it is a transient analysis, you can see the Van Orman vortex sheet here, the flow accordingly. And if you want to see the streamlines over, that means you can click the streamlines. Here starts from, you can give symmetry only, like 1000. I'm giving 1000. So I told, right, there is vortices behind the cylinder. So you can see how nicely the vortices are formed, how the vortices are formed for a particular in water, for particular velocity and a particular if because here we are not giving any rotation, only we are seeing how the back vortices are formed. So if I want to see in vector form, means again click on vector, location symmetry one, apply. Here you can change to maximum number of points, or else like, so this vector you can see in fluent more clearly. Will show how to. in results vector give new, and here select the cylinder, can save display. Sorry. If I want to reduce the size means also here we can reduce it. If I want to reduce it further means also we can do that. See how the vectors are formed, and you can see the vectors. The formation is also in the form of a series. That is because of the inflation layer, which we gave. If the inflation layer more perfectly, if you are giving means here also you can see the U type boundary layer that I will show. If for some cases we can run, and we can take for your the work which you guys will do. In that case, we can take all the things. So how the vectors are rotating, in that way only the streamlines will be like if there is a vector rotation is there means you can straight away say there is a recirculation region in either on any side of the or any side of the cylinder. So this is how we need to do the analysis for a particular that means a flow or a small object. So one exercise I want you guys to practice for and you should show the results which I showed. And here you can see here this region can be saved also. Like this, if you want to save this region in this way means see you can save that image also. Here one option is there. So you can save your picture here, JPG, and the scale which you should follow is like for like 4000 cross 3000. Then the image sizing and image will be very good. It will ask you just. I'm just saving in desktop. Okay. Now you can see your image in the desktop. Saved. Sorry, it did not saved in desktop. I'll give once again. So you can see here, like this you can save. This sample I have shown. Like this you can save anything, sir. depend upon your version which you are using, that will change. In most probably in many cases, you can get one camera image here. There, if you click, you can save this image like that. See this XY plot also, which we seen. You can check anything here. So, remind 1 minute. So like this, if you want to save, that means also you can write that to some file using this write to file option, so that you can use any other plotting softwares to plot this. Because in Ansys you will get some results, but if you want to plot in nice way, some data sets if you are getting, and that data sets if you want to plot in nice way, means you can use any other softwares. So for that option, we need to write that to file, so that it will be saved in some txt format. From that you can take and import in some plotting software, and you can do the things. So this is how we should do the analysis, flow analysis, external flow analysis for a 2D case. For anything you want to, what you want to do means you have to create a control volume for an external flow analysis for whatever analysis. Even for a 3D analysis, you have to create a control volume. And meshing part, we should be very cautious, like what type of results you want, accordingly you have to take the do the mesh and proceed the analysis. We did one small normal thing, so we didn't do much here. So and here one more thing is like see, the xy plot which is created here is like the positions from leading edge to trailing edge, not the curvature. If you want to do that, there are some options are there. In that way, we have can do. Now, what you do, the next class, before next class, you finish flow, same this flow or a cylinder exercise. And one more thing, once that is finished, means make two cylinders, one cylinder at the front, one cylinder at the back. So two circles you have to create with a distance of uh, 20 mm. The distance between the cylinder will be like 20 mm. Okay. So one cylinder, besides one more cylinder, behind that one more cylinder, and a control volume, same control volume like this. So you will get an idea how the flow behaves if two cylinders there. If three cylinder, if you want, you can go with three cylinder, four cylinder also, but at least you do with this one. Okay. That cylinder, one cylinder at the front, one cylinder at the back, make control volume such a way, and do the same analysis, and you check for different velocities. Now I have given 2 meter per second, you can check for different velocities also. Okay. So that's all for today. You have any doubt, you can ask. If you have any doubt, means you can ask.
Yes, I will. Yeah. So can you just tell me that if it is a 3D, like
Ah.
how these things will change? Like boundary condition will change, right?
Boundary conditions are similar, ma'am. Like in inlet and outlet only. Suppose
No,
if you
sorry.
want
That the intake values. Then
intake
how you're
values,
going to give a sample?
suppose if you want to do some analysis inside a pipeline, and same inside one cylindrical object, or some normal object is there, that you have
Right.
to check, means and under some pressure, if you want to check, means we should give the pressure value. This velocity inlet, we can change that to pressure inlet also. And we need to set the pressure values accordingly. Like total pressure, we need to set initially. Or else, if you want to know only the velocity, means general velocity, you have to set before setting that. In the Y plus calculator only, you can change the velocity and find the first cell height if you want precise results for some paper or some applications, or else it is not required. Generally, you can do by changing the velocity.
Yeah. Now, one more thing, as you have said that a two cylinder, right?
Yes,
And the distance is 20 mm, you said.
yes, 20 mm.
So when we have to take an outlet, we have to take from the outside only, right?
Anyone
Measure
you
the
can.
distance.
Actually, it's like it should be like a minimum. We need to give 5 to 10 times that distance, outlet distance. Otherwise, the flow behavior
So
we
will
cannot.
not get captured.
Yes, that's why we are providing that. But for specific applications, sometimes if you want to know about some in for some applications, the boundary is limited. Means accordingly only we need to give. So in that case, sometimes involved some shear is there. Means we need to specify the shear and the shear values we need to give. But here it is not. We are not doing anything about that. That's why I have not touched that wall part. If you are touch if you are not giving any values for that, means it will take no slip conditions. So no
Okay.
shear.
No, sure.
Uh, but if you want to do that, means again that no the slip shear conditions we need to provide. Inlet and
I
outlet.
have one more question.
Uh,
Like, if suppose we are finding or doing the analysis only about the nose of a rocket,
no, okay,
we
ma'am.
are not doing the rest of the body.
Uh,
Then, in that case, how we are going to analyze that? Because the
in that
rest of the
case,
body is existing, right?
without no need of the remaining part, means only the boundary should be like it's the replica of that particular rocket. The outer that means it should remain the same shape of the rocket shape boundary. In that case, or else one parabolic we can give, or else half circle we can provide, so that we will get the character cells remaining. What the end part we need to provide as a outlet.
Okay. So, can you
One
just handle
more question
one
is,
session for that?
do we only use this to describe the flow or a cylinder, and does it used in designing of various objects such as flow of gases? Yes, for flow of gases, flow in some pipe, same thing you can follow, but thing is like depend upon your conditions and whatever analysis you are doing, accordingly you have to design your control value. And if you're if you want some gases to be flown over a cylinder, means accordingly you have to change the fluid in the fluid database. That database I showed, right? Initially it is air, but I changed that to water. So water, how the database that I have shown, for some gases, means you have to choose from that one. If you want to add your own material, means that means own fluid, if you want to add, means that is somewhat difficult. You have to there is some format is there, accordingly you have to provide the details. Then one more question is there: inlet and outlet distance should be equal, or inlet and outlet condition, let it be equal. For the same inlet and outlet condition, we are going to check how the flow behavior over two cylinders, that's all. Whether the drag will be less, or we cannot here also one more thing. If you are select giving drag, means don't give for two cylinders, any one cylinder. We cannot check two cylinder at a time, or else two cylinders you can check different in monitor report plots. You have to generate two drag plots, one for cylinder one for cylinder two, like that you have to create.
So, Jenny, can you just confirm that when will be the next session?
I will confirm you, ma'am.
Okay, okay. Actually, it was supposed to be Tuesday and Thursday. So just let us know. Accordingly, we will shoot ahead
Okay,
to
ma'am.
our
Okay.
interview. Okay.
Mm.
Okay.
Ah,
Thank you so much.
thank you, ma'am.
So, yeah, this session is recorded, and we will share this session video with you all. And as I have said that he has given you task, so it is very important to practice. So please, next class, but today itself we can start practicing. And if you have any doubt, just let us know. Right? Okay. Thank you, Jenny. Yeah. Thank you.
Thank you, ma'am.
Yeah. Okay, good students. Good night then. And okay, as sir have taken today about the flow over a circular cylinder, there is only one cylinder over there. So you have to do is a two cylinder, and the distance between apart from this two cylinder is at a 20 mm. The diameter of this cylinder is around 10 mm, but the distance between two cylinders of the same size, it will be around 20 mm. Okay, so you have to do the flow analysis and get it ready. Is it clear? All right. Okay. Good night, everyone. Then. Thank you, everyone.